everyone. My name is Michael Goff, and I'm Principal Product Marketing here at Revenera, and I'd like to welcome you to today's webinar, Monetizing AI, Comparing Pricing Models and Monetization Strategies. As generative AI, or GenAI, becomes integral to modern products and services, technology companies face major challenges in effectively monetizing it. In doing so, there are many questions to consider, including, should AI be part of your core offering, offered as an add-on, or provided as a standalone product? And how can software producers leverage statistical experiments to test pricing hypotheses and assess the impact on revenue growth? With all of that in mind, I am very excited for us to hear from today's speakers, innovation coach Tristan Kromer, who is founder and CEO of Kromatic, and Alex Rybak and Paul Bland, who are both senior directors of product management here at Revenera. And they're going to share their insights on evaluating different pricing models, estimating costs, and developing strategies to ensure that your AI capabilities drive profitability. Before we get started, though, let's go over a few housekeeping details. First, today's discussion will be roughly 45 minutes long, and if you have any questions or comments, please add them in the chat tab, and we'll try to answer them as we go along or at the end if time allows. And if we don't get to your questions, don't worry about it. We will follow up with you individually after the event. Also, please be sure to check out the Handouts tab, where we have a number of resources related to our topic today, some tools and templates that Tristan has provided, and a copy of our recently published Revenera Monetization Monitor, Software Monetization Models and Strategies 2025 Outlook. Finally, we will be sending you a link to the recording in the next 48 hours. So with that, let's get started. And I will hand things off to Alex. Alex?
All right. Thank you, Michael. Thank you, everybody, for joining us today. So as Michael mentioned, myself, Paul, and Tristan will talk about monetizing AI today. We are going to do this in three parts. I will start off by giving a little bit of an industry background, what's happening today, talk about different real-life examples of how people are monetizing their AI capabilities, talk about the costs, which are really important if you're going to be measuring ROI and doing revenue modeling going forward. You need to understand what costs you're going to incur and how they're different from traditional SaaS and cloud offerings. We'll talk about how to price certain AI features and how companies out there are doing so. And then I'm going to hand it over to Tristan for the more practical portion of the webinar. He's going to run us through some statistical experiments, talk about how we can model ROI with various inputs and kind of see what that leads us to with the resulting numbers. And then we'll hand it over to Paul to talk about some of the solutions we have available that can help you along your journey. So let's start with a few metrics. So we've been looking through various reports published by IDC, and I wanted to pull out just 5 kind of key numbers that are pretty good at setting kind of where we are with GenAI in industry today. So the first one is really encouraging. From what they are seeing, about 80% of people that are purchasing AI solutions, whether they're standalone or just capabilities as part of their existing software that they buy, are generally happy with what they're getting, and over 60% are willing to pay more for AI capabilities. So clearly, we're early on in the journey, but people are already getting values for their investments. So that's a really good place to be. With anything, there's concerns, right? So the top 3 concerns people have with AI are, number one, security. So about half the people are concerned about security. 39% are concerned about costs, and this is important because it's not necessarily a linear cost, and it's certainly a variable cost. So it's important to understand that with respect to your budgeting. And then, of course, data quality. We've got about 61% of the people concerned about data quality, making sure the data is accurate, that there's minimized bias in the data, and it's generally adding value to what you may be doing today manually. When people shop for software, almost half the people consider AI features as critical criteria. So for the software producers on the call today or part of this webinar, it's important to understand that half the people that you are selling to are likely going to look at what AI capabilities you have in your products. And if you don't have them, or if you aren't marketing them, that may influence purchasing decisions. So something to consider. When people do invest in AI capabilities, about a quarter of them are seeking productivity improvements from their employees, and time to market and speed deliveries as the biggest motivators when they're purchasing the capabilities. So again, if you're just starting and wondering where to invest, that's where the quarter of people are looking for improvements when they purchase AI capabilities. And then on the pricing side, there's really 3 models that are driving for AI capabilities. So number one, consumption-based model. Number two, subscription-based, so access to a particular service or AI application. And then 21% outcome-based. And outcome-based is an interesting one because you are not just paying for use or access, but you are paying for actually deriving a business benefit out of using an AI capability. So think of it as automatic closure of a support ticket. And for each ticket, you pay a certain amount based on successful completion of that process. So when we look at software producers and kind of top of mind considerations, there's really two things that people are thinking about in the beginning. So number one is as they dig into it, they realize that traditional monetization models don't always work for AI. The reason for that is that if you look at subscription-based or user-based, they aren't a really good fit because they don't account for variable costs. So if you are paying, $30 a month for a subscription to software, and that vendor adds in AI capability, the more you use the feature, the more costs they incur, and they start eroding their margins. So you need to have some sort of combined model where you are taking care of your fixed subscription costs, but you're also accounting for variable cost. And then the second thing people look for is, well, how do I take this to market? Is this going to be an enrichment model where I'm going to add AI capability as part of my existing offering and adjust prices accordingly? Is this going to be an add-on, right? Is it going to be a new module that I want to add along with an existing offering, perhaps for a different price or different monetization model? Or is this going to be a brand new offering, a brand new standalone solution, standalone new offering, and how do I go about pricing it? The other thing to consider, though, is very often you may already be using other vendors' capability in your product. You might be white labeling analytics capabilities or reporting, and those vendors may already offer AI capabilities. So how do you price that? How do you take into account additional costs on you to have to pay that vendor for their capabilities? And then how do you make sure that passing that along to your customers, you're not eroding your margins? So later in this webinar, Tristan's going to talk about how software producers can leverage statistical experiments to test their pricing hypotheses and assess the impact on their revenue growth. So let's spend a couple of minutes and look at some typical AI costs, right? So when you look at AI costs and you want to determine kind of the increased costs to your current cloud expenditure, you need to look at multiple factors. You need to look at the type of workloads you're going to have, the scale of usage that you're going to have, because again, there's the variable costs. So very often it's going to be tied to complexity and tied to overall use. You need to look at a choice of cloud service vendors and which cloud services you're going to purchase from them, complexity of the models. All of these elements are going to greatly influence the cost. So what we've done here is we've promoted kind of 5 high-level categories to consider. There's clearly a lot more, but this gives you some idea of where to start. So the first one is model training. This by far is the most expensive. This is something that is generally cost prohibitive to most organizations. The cost here can run the millions or even in the billions. So most organizations are going to use an off-the-shelf large language model or an LLM. They may also use technologies which allows them to combine these models with external knowledge bases and augment it with their own data that makes the model more relevant to their domain and their customers. But this is typically a massive upfront cost, and it's just mitigated by using things that are already available in the industry. And there's several repositories that offer language models. The second element to look at is the processing costs. And typically, if you look at the processing costs, you're looking at when you run models in production, they require compute resources. And as you increase the demand for the compute resources, especially if you're talking about real-time application, low latency applications, so things like recommendation engines, chatbots, your processing costs are going to go up. And generally, kind of back in the envelope calculation, expect about a 20 to 50% cost on top of your current operations costs. Third bucket, storage data handling. So clearly, as AI models are used, they rely on large data sets. In turn, these large data sets increase the need for storage and data processing. So training data needs to be stored, it needs to be pre-processed, it needs to be regularly updated. And this in turn increases costs for both storage and data transfer. Again, back to the envelope, about 10 to 20% on top of your existing cloud costs. Then we get into specialized AI services. So these are things where companies maybe leverage managed AI services from Amazon, from Google, from Microsoft via Azure Cognitive Services. All of these typically come with additional premium costs, and that needs to be accounted for, typically another 10 to 20% on top of your current cloud costs. And then the fifth bucket is scaling requirements. And this one's very important because upfront, you may not have a real good idea of how much actual use your new service will garner in the market as you go live with a product. So it's important to understand that your service will need to scale rapidly as usage increases. So if a product uses AI for personalization or recommendation, every user interaction could potentially trigger AI calculations, and that leads to higher compute demands. So it's important to have some assumptions and modeling going in, and then frequently revise this as you get more adoption into your products and services. So if we roll all this together, for something that is a small scale or occasional use, so things like a chatbot or a small recommendation engine, typically it's going to be an additional 10 to 20% on average cost over your current cloud and operation costs. If you're looking on the other side of the scale where you have a large scale AI deployment, significant training, real-time inference requirements, advanced personalization, deep learning models, things like that, that's where your costs can be up to 50% or even 200% or more on top of what you are paying today. So important to understand kind of where you are and where your roadmap leads you with future capabilities as it gets more adoption by your customers. So let's look at a few examples. So here's 5 real-life examples of companies that have offered AI capabilities either as brand new offerings or as modules or just as additional capabilities into their existing service. So all 5 of these are different approaches to monetizing the AI capabilities. So if you look at Adobe Creative Cloud, it is a subscription-based service. And what they've done is they've increased the price by 10% on top of their existing subscription costs. And they've included a bucket of credits for use of their AI capability. And they offer extensibility by purchasing chunks of 100 credits for $5 a month. Right? So essentially, you're paying for access to an existing service with new AI capability, and then you're paying an add-on cost through tokens or credits for their AI capabilities. If you look at Zendesk, Zendesk is an example of an outcome-based one. And what you're doing is you're paying for value, right? So it may be low volume, but you're paying for high value where you are eliminating a human from the process or greatly augmenting a human to automate an outcome like resolving a support or IT case automatically without the use of a human. And then there's a cost for each of those successful resolutions. If you look at Zoom, Zoom incorporated AI features into their existing subscription. Their prices change, but ultimately, as long as you are a pro or business subscriber, you have access to their AI capabilities. So you're paying for access by users based on the plan that you have. You look at Microsoft Copilot. You're paying for access by the user. So it's a subscription-based add-on cost on top of your existing subscription with Microsoft. You're now paying an extra $30 a month per user per month billed for enterprise customers. And then finally, Otter AI is a transcription service for meetings. And here you are paying by use. So you're paying consumption-based based on the number of minutes that you are using their capability as part of recording and transcribing your meetings. So 5 different examples, 5 different approaches to how to monetize AI capabilities. So with that, I will hand it over to Tristan to walk us through some modeling exercises.
Thank you very much, Alex. I also want to encourage everybody to please ask questions or challenge me as we go on. This is going to be a lot more interesting the more comments that you ask. I do want to make this as practical as possible. My background is from innovation, not specifically AI. So we've got Paul here to answer any detailed AI questions and Alex here to answer any questions about pricing. But my expertise has always been in figuring out how are new ideas viable. How can we tell if implementing a new AI feature is actually going to be worth the money? Or are we just kind of crossing our fingers and hoping for the best, hoping that eventually the tremendous costs of AI will come down enough to make all these features worth it? So I want to give you some practical advice about how you can go about doing this, some cautions as to what can go wrong if you do this in a sort of traditional financial modeling approach, and hopefully gives you some ideas of how to approach it slightly better. So that said, I am going to go relatively quickly. So I'm going to skip through a little bit of the song and dance because I want to spend as much time on kind of QAing and details as possible. but I will just show you a few slides. For starters, I've worked with a lot of companies and a lot of accelerators and a lot of corporations and a lot of governments talking about a lot of different innovations, everything from ice cream. Literally, I served on the ice cream innovation board for several years at Unilever, to high technologies such as at Salesforce and LinkedIn and so forth. So what does AI have in common with all of these interesting innovations is that it's new and unpredictable. It might dominate and enslave the human race, or it might become our ultimate savior. We're not entirely sure. All we know right now is that there are many different reasons why you might want to implement AI. And some of these reasons don't really require any financial justification. I've heard a number of different clients that are eager and quick to implement AI because they just want to be offensive. They want to get a PR boost. They want to enter adjacencies very quickly. They just want to be the first mover. They're not even attempting to justify financially their reasons for implementing AI features. They just want to move fast. And they're just assuming that the cost will come down eventually and they'll be able to afford it. Okay, fine. No need to worry about anything I'm saying. You can just go off to the races. Other people are being very defensive, and they're saying, well, our competitors are implementing these features. If we don't, we're going to be left in the dust. That immediately becomes very significant and an issue. But again, you don't necessarily need to, as a product manager, come up with a very complex financial justification. On the other hand, when you start dealing with implementing AI features either on the back end or something that really adds value to your customer segment, you do need to, as Alex discussed, figure out how you're actually going to pay for these things. What is it going to do for us? Is it actually going to allow us to increase our prices, like the survey said? Or is it something maybe hidden in the back end and just allows us to reduce our costs about how we deliver our services? There are many different reasons strategically for doing this. I'm going to focus primarily on the latter. I want to discuss what do you do when you're offering a service, such as Zoom, and you're adding these AI features, but you need to figure out how to pay them, how to pay the costs, or you need to figure out what exactly will the costs be. So meaning you have some sort of idea, and you're going to roll out a feature. Maybe it's going to be a nice, happy, friendly AI chatbot that's going to help everyone. Again, maybe it's going to be massive overkill, and it's going to be the death robot that helps you with your light homework, housework. But either way, we need to figure out exactly what that means. So when you pitch this idea, when you've decided what you're going to implement, and you say like, all right, let me just throw this into the roadmap, what's going to happen is eventually somebody will come along with a calculator and ask you, well, how much is this going to cost? How much money are you going to make? Eventually, this will rise up to the level of the C-suite, and they will ask you to make some strict decisions because they want to implement AI. Everybody's very excited. Everybody knows how much AI is impacting us on a day-to-day basis, but the costs are prohibitive. As Alex pointed out, these costs can, in some cases, increase your variable costs from 100 to 200%. That is significant and can actually crush your business. So what everybody wants is to understand what are the pricing models that are going to be effective here. Alex already went through most of these, so I won't go through them entirely here. I'm going to talk a little bit about usage-based pricing, but really freemium, I think, is the one I'm going to focus on today. But we can discuss any of them because you have a very limited amount of time to figure out how pricing works. We are all assuming that in the long run, the costs will go down. But it looks like it's going to be much longer than we all think. The AI technologies are obviously on some very, very steep exponential curves. But we have a limited time to figure out how to pay for them before they impact our business. And as a product manager, the traditional innovation approach, or I guess I should say the more modern innovation approach for the past 10 years has been very much to create a hypothesis on a business model canvas like this, a whole bunch of sticky notes about what amazing value you think you're going to add, and kind of cross your fingers and hope for the best. But that doesn't really cut it anymore. particularly in the macroeconomic for the past 2 to 4 years, people have really demanded a spreadsheet of many, many numbers that may or may not instill panic in you when you are asked to create this massive spreadsheet of numbers to justify our costs. But CEOs and CFOs in particular are no longer willing to accept just a rough hypothesis to justify a massive expenditure like this. So we need to figure out how to create a spreadsheet that accurately models what your potential revenue benefits might be, and figure out also how to model out those costs. And the traditional way of doing this is just to shove everything in a net present value formula and magically create a chart that looks like this. This is what your C-suite wants to see, right? They want to see a chart that says, when I implement this feature, I am going to have a massive increase in my profit. That's basically what they're asking for. And the way that we do that today in most large corporations and some smaller ones is we tend to create a best case scenario. This is a real one, by the way. We tend to create a best case scenario, and then we create a worst case scenario. And then everybody thinks you can kind of just get by dividing those two things in half and passing that off as a prediction. Unfortunately, that is not the way innovation works. It's certainly not the way modeling AI is going to work effectively. And the reason for that is pretty obvious. It's the level of uncertainty involved, right? Whenever we make a prediction, especially if it's a straight line prediction like this, or like this, or like this, you're basically providing a tremendous amount of precision with very little accuracy, right? In this chart, it's proposedly saying that this particular product offering is going to generate at least 250 million by November 2025. That's obviously nonsense. It's extremely precise. It's a very precise number, but it doesn't count for the level of uncertainty that is between the worst case scenario here and the best case scenario. This looks fantastic. This looks absolutely terrible. And this is just arbitrarily guessing at what might happen in between those things. And the reason for that is, of course, that innovation is not entirely predictable. Innovation is much more like playing poker. If we get a pair of tens for our whole cards, there are a number of different possible outcomes here. We could wind up with a full house, or we could just wind up with a pair of tens. We could wind up with what we started with. As an innovation person, as a product person, you have some things that are known and some things that are unknown. You know your technological capabilities, I hope. You probably have some decent hypotheses as to what's going to be available in all of these different large language models in the next year. You hopefully know that there are some really cool things that you can do with small models with very little training data. Over the summer, I was able to play around with training a model to recognize human beings in a LiDAR image array. And that only took about 40 different training images, and we were able to get it working really, really well. There are some pretty amazing things you can do with AI that don't require billions of dollars. But there are those big unknowns as to whether or not our AI right now is about, I'd say, the level of an unpaid, unmotivated intern. I believe in the next year that we're probably going to get a college grad out of a lot of these models, but maybe not. Maybe we'll get a lot more. Maybe we'll get a postdoctoral fellow out of these AI models. We're not quite sure. These are unknown impacts, and we certainly don't know how our competition will react to these changes, whether they'll adopt things faster or slower than us, whether or not our own training data, whether or not our own RAG models are going to really provide a unique differentiator, or are all these models essentially going to give everybody the exact same tools because no one can afford to build the billion-dollar custom model? These are all uncertainties. So when we're talking about innovation, we need to talk about placing bets. We need to talk about how much you're willing to bet on your pair of tens, and whether or not it's the risk of, potentially having the worst case scenario happen, or whether or not it's worth the risk of maybe getting that billion-dollar idea. So if you're not familiar with poker, if you're not comfortable with that metaphor, I would encourage you to think of this like the weather report. The weather report is a wonderful way of how we should be predicting things, because the weather report generally doesn't tell us that, 1 week from now at 2:15 p.m., it's going to start raining. It doesn't say that. It doesn't give us that level of precision, because the greater level of precision that the weather report offers, the more they know that they're likely to get a lot of angry phone calls. Instead, the weather uses a different approach. They express things in probability. Those of you in the United States have certainly seen this sort of chart more and more through the years. This is a wonderful way of expressing uncertainty in regards to a future-facing development. This is a hurricane, obviously. This is a hurricane which is at 5 a.m. Tuesday, right at this spot. Right? We know where it is right now. The present is known. As we move into the future, as we get to 2 p.m. Wednesday, 2 a.m. Thursday, 2 a.m. Friday, 2 a.m. Saturday, 2 a.m. Sunday, the cone of uncertainty starts getting wider and wider, because there are many different variables which influence the potential path of this hurricane and the strength of that hurricane. And so this accurately depicts for us what might happen. We know that New York City, where New York City is way outside of town. So New York City, in this case, is not going to get hit by this hurricane. On the other hand, parts of Massachusetts might get hit by a tropical storm later. North Carolina has a significant chance of being hit, but not so much as Florida, it looks like. So this is a wonderful way of expressing probability, right? That closer to now, we know what's going to happen. Further on into the future, we don't know what's going to happen. And this is the type of modeling we want to use in our financial scenarios. The key here is something called Monte Carlo simulations. Essentially, what the Weather Channel is doing here is they know certain things, right? They know what the temperature of the water in certain locations due to certain sensors placed around the coast is. They know what the dew point is. They know what the humidity level is in various different situations, but they don't necessarily know those things in the future. They have some estimates, and they can estimate those variables in certain ranges. They know that the humidity is going to be somewhere between 30 and 40%. And what they do to create this graph is they throw all those ranges into a computer simulation and have the computer essentially spit out random numbers between those ranges according to a certain distribution. And they run that simulation several thousand times, in some cases tens of thousands of times. And what you're seeing now is an output which basically summarizes the results and summarizes what is likely to happen based on all those different variables. And that's called a Monte Carlo simulation. This is a far superior way of predicting the future than something like this, right? Again, this is a highly precise prediction, but is almost certainly wrong. We are sacrificing accuracy for precision here. And my proposal to you is that the better way to do this, especially for highly uncertain projects like implementing a new innovation, whether that's an awesome new ice cream flavor or whether it's adding a new generative AI feature to your product, is something like this. This is a hurricane chart for financial model. This particular one shows that you are quite likely to be earning at least somewhere between 20 million and negative maybe 2 million. That is the most likely range of outcomes with this particular innovation. However, you could be making as much as 60 million per time period here per month, or you could be actually losing a tremendous amount of money, over $20 million per month. That would be a very, very serious problem. And what we want to do is really, as innovators, is understand the inputs, understand the variables that go into this sort of forecast, and then gather information so that we can reduce the level of uncertainty, so that we can reduce the cone of uncertainty. Now, I want to get into how we do some of that. I want to show you some examples, but I do want to emphasize for those of you who might still be using kind of best case, worst case divided by 2, that is not a good way to estimate things. My experience is that most best case, worst case divided by 2, which I would call the basic business case, radically overpredict the amount of revenue or impact you will have. In some cases, the actual realization of the revenue is only 30% of what is predicted. Meaning, if you predicted that your product would return $1 million, it will only return, in some cases, maybe 300,000, maybe in some cases even worse. In fact, if you model out these different scenarios, I'm just now showing you the same model, showing you best case, right? That's this top line. Worst case is way down here. And the basic business case predicts, again, 250 million per time period. But if you actually model these out with a Monte Carlo simulation, that is using a range for all your variables and seeing what happens if you simulate the outcome several thousand times, is generally the prediction of the Monte Carlo simulation is much more accurate and much lower than your basic business case. Meaning, if you just use your best case, worst case divided by 2 and cross your fingers and hope for the best, you are probably going to have a very angry conversation with your CFO or your CEO after the launch of your product, because your predictions are going to be wrong. Monte Carlo simulation is a way of getting much more accurate predictions based on clear hypotheses about the range of your possible revenue, the range of your possible costs, and so forth. So that said, I'm going to pause here for a second. I know I'm going reasonably quickly. I want to, again, encourage you to put your questions or comments in the chat. If I am saying something too fast, please stop me. Okay, that said, you're probably asking yourself, how the hell do I do that? It's not as bad as you might think. I know a lot of people, like myself, I used to have a strong aversion to whipping out a spreadsheet and modeling out my product hypotheses. I'd much rather just say, like, hey, I think this is really desirable to our customers. I think they want it. Let's just go and build it and see what happens. But there is a relatively simple approach which we can use to model these things out and put them into a Monte Carlo simulation and come up with those ranges that Chancellor is asking about. I'm going to walk through the process relatively quickly, but then we're going to get into, I just want to look at a model so that you can understand how you can use a traditional financial model, the benefits of using a Monte Carlo simulation, and when you can use each one and just kind of see them in action. So the basic process is something we call innovation accounting. That sounds kind of like a contradiction, but it's not. It basically involves 4 steps. Mapping the impact that you want to create, whether that impact is profitability or perhaps lives saved or tons of CO2 removed from the air, whatever it is, understanding the cause and effect of how you create that impact. Then creating a basic model in a spreadsheet. Third, quantifying uncertainty, which is where we need to talk about getting those ranges for the variables. And then lastly, making a decision based on that input. So again, if you're kind of into modern entrepreneurship, you might have a way of mapping out your hypotheses, such as a business model canvas or a customer persona, something like that. What you need to do in terms of creating a cause and effect understanding of what is going to create more revenue or create more lives saved is you need to map out a complete map of your user journey or your customer journey. That could be something like this, which I mocked together for Instagram. It's just a sequence of events, right? Like, what happens? People sign up, they see something beautiful, they take a photo, their photo is miserable, like most of my photos are absolutely terrible because I'm bad with camera. And then you take it to your amazing, in some cases, AI editor, and the AI editor makes that photo awesome. Great, amazing. And then, of course, way at the end here, you're famous. You can map something out like this. You can map it out with words, Here's an example that's just kind of somebody creating an analyst report. And you can see they're just mapping it out with words and icons. The reason for doing this is just to understand the sequence of events and the types of user behavior that is actually going to drive conversion, upsell, cross-sell, whatever it is that you're trying to map out. But what are the things that will cause increased conversion rates? Like, what has to happen? I know in this Instagram model that, if I'm not delivering amazing photos, if the percentage of pictures that are improved by my, excuse me, that are improved by my AI editor are not good, that is ultimately going to impact my retention rate or my acceptance rate of the new product. So this is a skill that most user experience people have. This is a skill that most product people can adopt very, very easily. No spreadsheeting involved. But this type of very basic storyboard does allow us to identify metrics, right? And those metrics are simply the conversion rate from one step to another. And that's incredibly useful. Pardon me. This allows us a way to bridge a conversation that we're having with our user experience people to something that is a little bit more financial, like this. This is a hypothesis-driven financial model. I want to differentiate this with a traditional financial projection. This is a traditional financial projection. Please don't ever do this. This is what a lot of people ask for. And they basically want you to just put numbers into a spreadsheet showing this is what you're going to earn in 2028 in Q4. Excuse me. So if I put a number, I'll make this a little bigger so you all can see it more easily. If I'm just typing a raw number into this spreadsheet, this is a useless prediction, right? This is not testable because I'm predicting here that I'm going to earn 3,000. I'm assuming this is in thousands, so $3 million in Q4 in 2028. That is not testable until I get to 2028 in Q4 and I see the results. That's useless for us. It's 2024. I'm not going to wait 4 years to make any product decisions. So this old approach of traditional financial projections requires you to generate a hypothesis for every single time period and every single variable, including advertising expenses, 4 years in advance, which is absolutely useless. The goal of a hypothesis-driven financial model is really to understand what are those key drivers, such as conversion rate, that come from your storyboard, right? What are the user behaviors again, or the behaviors perhaps within your back-end organization that really drive different impacts in your model? So what I'm trying to do with this sort of model is identify all those variables from the storyboard and then construct a model which uses formulas, right? Uses those variables in formulas to predict the future, right? So that way I can tell that if I have 6,440 new users in April of 2025, and we have some returning users, that means I have a total of 12,000 users. My anticipation here is that I have 50% of conversion rate of users that become customers, and therefore I'm going to get that nice number multiplied by my assumption. What this does is it gives us a very basic spreadsheet, which I can now play around with and see, well, if the numbers change, if it turns out that my actual conversion rate is only 10% and not 50%, what does that do to our profit and loss? This type of model is a massive improvement on the traditional financial model. Most companies do some sort of variation of this, but usually with very few variables that are actually not user driven, right? So they'll have things like cost of goods sold, but you'll, again, just be putting raw numbers in terms of how many units you sell. The idea here is to really map the user behavior with your financial model. So that makes everything very testable, and because I can put a minimum viable product out into the new, I can put it into the market, even with a small number of users, and I can actually see what they do, right? So even if I have as my hypothesis here that 50% of my, sorry, I'm gonna change this because my OCD will bother me, users that become customers. If I get 100 people using this product, right, and I assume that 50% of them will actually upgrade to a premium version and become actual customers and pay me, well, if I put even 100 people into that experiment, into the MVP, and it turns out that only 10% convert, that gives me a lot more data that I can update my assumptions with. Now, the problem, which I'm assuming that Chancellor, who's apparently very, very happy, Chancellor is asking about, Chancellor probably knows that if I run an experiment with 100 people and it turns out that only 10%, so 10 people actually become customers, there is a massive margin of error on that experiment, right? If I run 1,000 people through that same experiment, I might get a very, very different answer. And that is captured in the margin of error, right? So the margin of error is based on the sample size of people that I run through this experiment. So particularly if you're a B2B or B2G, even worse, if you're a B2B startup and you're dealing with much smaller sample sizes of customers that are adopting and using your product, or you're running a B2C product in your very early stage, you can only afford to run a certain number of people, you're not going to get very accurate answers from your early stage experiments. That's something we need to deal with. So we need to understand, how can I shove two different numbers into this box so that I can accurately say, well, I ran an experiment, but it turns out that maybe only 5% of users will convert, in which case I am, colloquially speaking, screwed in this business model, but maybe as high as 50% will convert, in which case I'm doing great. I'm earning 400 grand a month. This is looking good. And the answer to that, again, is by using a Monte Carlo simulation. So, I'll again take a brief moment and remind you, if you have questions or if I'm going too fast, please let me know. But I'm going to try and burn through a couple more things quickly, and then we really, really want to talk about actual ways to implement pricing in your model. So this is a SaaS model. You can a freemium SaaS model. By the way, I should mention that if you want to follow along live, we did put a link to this spreadsheet directly in Google Sheets. And you can access it in the handout section, and it's called Kromatic Financial Model Template. So in this model, what I've done here is I made a quick example with AI freemium that is essentially the same model I just showed. We've got our conversion rate from visitors becoming users and users becoming customers. I've got my revenue per customer, and I've got some additional costs. Basically based on, well, how many tokens are these visitors using if I'm letting my people who haven't even signed up test my AI tool, or if I'm letting them use my actual product as kind of free users, like how much access am I giving them? And how much access should I give them as customers? How often are they going to use this? Because this is a little bit like a gym membership. Like, my goal as a gym is to get as many people signed up for a monthly membership, but have as few of those people actually go to the gym as possible. So Paul, let me ask you here, give me some ideas here. Let's start with only allowing people who pay us to use our premium AI features as a basis here. So we want to model the same SaaS product, but we're going to add an AI feature and only let paying customers use it. So Paul, how's my cost per 1,000 tokens? Is this reasonable, or should I change here?
So you're initially suggesting 5 cents per 1,000 tokens.
Yeah, and that's roughly ChatGPT type prices.
Yeah, I mean, I think that's I presume that you're saying, well, let's have a starting point, right? Model it out, see what happens, and then see what happens if we change the price for the token. And I think that's fine. My experience is a lot of people are saying, well, what price do we start with our tokens? And this kind of model, I think, that you're going to take us through gives you a way of kind of answering that question hypothetically using levels of confidence.
Exactly, right? So let's make some assumptions to start with. Let's assume we're only giving this out to our premium customers. How many tokens do you think those customers will use each month, right? And remember, here's my massively profitable business right now. Let's see what happens when they start using our AI tool. So how many tokens do you want to add in per month, Paul?
Well, I mean, let's start with I mean, this is a business, right? Let's start with 1,000 tokens.
Okay, so per user per month, 1,000 tokens.
Per user per month. Yeah,
per user.
Well, why not? It's a great tool. It does the job, and it's free.
Right. So right now, I've just given it to my premium users, and what happened is my profit and loss immediately inverted, of course. Right, because now I'm just generating a tremendous number of costs, and I haven't increased revenue at all. So now I'm losing almost 1,500,000 each month. So this type of tool now starts to allow us to play around with things. We can, as you say, hypothesize, well, what happens if the costs change? Now it's much less bad. We could also model out if this cost decreases over time. But clearly we have to change things, right? So this type of model, before we get to a Monte Carlo simulation, allows us to say, well, obviously we need to price this in, right? Otherwise we're in big problems. And in this case, we're sticking with the Zoom model. We're just going to increase the revenue per customer, the monthly price, and not do a per consumption model. So let's try raising the price by $5. That is not going to close the gap, right? Another $10, still not going to close the gap. Let's try 40. Okay, now I have something. I'm still far less profitable than I was before, but I can see that if my assumptions hold true, I need to increase my price by at least like $20, almost doubling it to pay for this increased usage. And God forbid I start giving this to my free users, and let's say they only use 500 tokens per month. Well, again, I have serious problems. And this is what Alex was saying. You could, of course, increase your cost by 200%, and that would be a significant problem. Now, let's address Chancellor's question, right? Because this is a very good tool, and I encourage you to use this. There's a bunch of different examples of two-sided markets and nonprofit in this template that you can access via the link. But you can play around with this and try out different scenarios and make your own model. These are very basic models, right? This is not incredibly complex. These are just ways to do what ifs. What if I do this? What if I do that? And get some basic parameters around, well, I know that if I can't get my users to pay this amount, I'm going to have a problem. I know that if I add in this feature of, again, let's say 1,000 users per month, I either have to increase my costs tremendously, or maybe this better increase my retention rate. Whoop, that's not going to help. So maybe this better increase my customer acquisition rate, right? A lot. It's not going to help. I got to increase my costs somewhat. So it allows you to play what if and try out a number of different scenarios and see what will actually work. Because in many cases, you can tell very quickly that your hypothesis is a bad one just from this level of modeling. But we want to get over to something that's a little bit more sophisticated, like this. This is a much more complicated spreadsheet, but please, again, do not panic. There are ways to convert this model into something like this with the click of a button. And what this is doing is basically everything is the same in this model. All the logic is the same. It looks a lot more complicated, but all the logic is the same. You have exactly the same logic over here. And the difference is that I now have a range where I can add the best case estimate and worst case estimate into all of these different variables. So instead of just saying that I know that my activation rate is going to be 50%, well, my activation rate is somewhere between 30% and 60%. And what that allows me to do is express the level of uncertainty, right? I can express with the width of the range how certain or uncertain I am. Because if I'm very certain that my activation rate is somewhere between 60 and 55%, that's pretty confident, right? So when I run a B2B experiment and I convert a small number of people, like 10 people, onto my product, by running that experiment and actually selling it to a small number of people, it gives me some level of information. Unfortunately, like I said, it has a very large margin of error because it's a small sample size. The bigger the sample size, the smaller margin of error. But here is a prediction on one model, which again shows a very wide range where in some cases I'm going to be making 25 million a month. And in some cases I'm going to be making zero. What it allows me to do is I can actually run an experiment. And let's say I run an experiment and I get a relatively high sample size. And I can run an experiment and reduce that margin of error. Then what I can do is I can recalculate with my new assumptions, the new information I've gained, and I can see that information change dynamically. So, whoops, did I hit the right button? Dun, dun, dun. There we go. All right, and now my level of uncertainty is much improved. It does look like I'm going to could be earning even up to 35 million per month, but there's still a lot of uncertainty in this model. So the last thing I'm going to show you, and then I want to shift over to Paul to talk about and discussion here, is you can also use this type of model in order to understand what are the variables, where is the uncertainty coming from in the model. I can run an analysis called the sensitivity analysis, which tells me that in this particular model, the biggest range of uncertainty is coming from the revenue, because my revenue hypothesis here is that I'm going to earn somewhere between $30 and $5, and that is a very large level of uncertainty. So if I run an experiment and reduce that level of uncertainty, because I can see how much people are actually willing to pay, I can again recalculate. And then what I can see is that the uncertainty from revenue per customer has gone down. And the biggest impact to my model is now the referral rate, and I'm much more profitable. So that said, I'm going to bring up the SaaS model just so you can know that this actually works in my AI model as well. But I'm going to hand it over to Paul as soon as I've got this on the screen, just because I want you to believe me that the same thing can be done with the exact same model. And I can see dynamically that I put the same assumptions that we had in before, but with ranges. And you can see again that the profitability of this model, which you can see this nice little S-curve here, is represented accurately by my best case scenario, which you can see is very, very tiny here. But in general, these assumptions that I put in end up costing my company a tremendous amount of money. So that said, I hope you understand the power of this model, but I'd like to pass it over to Paul because he needs to talk about what you actually need to do to validate those assumptions.
Yeah, thank you. Thank you, Tristan. And I mean, this has been really useful, Tristan. One of the questions that often gets asked is, where do we start with pricing? How are we even going to, get any kind of ideas with pricing, and how are we going to validate those initial ideas? In recent months, Revenera have released a new monetization capability within a platform called Dynamic Monetization. We've introduced a monetization model called Elastic Access, which allows producers to sell metered tokens to their customers as a means of charging for really any kind of portfolio access. But it particularly lends itself to this context where costs are extremely variable and have a large impact on revenue generated from subscription. And in fact, sort of any variable cost feature really needs a variable revenue way of monetizing it. And so consumption is a natural way to charge for that. These tokens are sold on a prepaid drawdown model. They're pure consumption tokens. And so they provide a way to be able to monetize against those variable costs. So we've talked about, or I've talked about the various use cases for elastic access over the past few months. And here's another use case: to be able to be able to charge for GenAI features on a pay-per-use basis, which really addresses the inability to offer these kinds of premium features. Although, you know, you could argue that GenAI actually isn't premium features. It sits at the heart increasingly of software offerings. But really what it does is reduce the barriers to be able to charge for those premium features. So, and to provide in the process your customers with a really flexible and cost-effective way of charging for GenAI. If you attended the webinar in September where Mark Thomason, one of our analysts, talked about what he sees in the market for monetizing AI, you'll recall that there was a kind of preference among producers to charge for GenAI on a prepaid basis, but a preference on from end customers to use and then pay, a post-pay model. Elastic access can be made to provide both of those models depending on what producers decide to provide for their customers. And this diagram kind of illustrates what you end up with, which is a blend of the constant revenue from a subscription together with the variable revenue from paying by consumption. And that variable part covers the variable aspects of your costs in order to maintain the bottom line, which is the ultimate goal. And in order to get started and validate those assumptions, to start with your Monte Carlo simulation, which gives you a projection, a forecast, and then kick something off, generate some real data, and compare that with what you've seen on the Monte Carlo, thereby and therefore adjust your assumptions based on what you've seen and see as time progresses how things are adjusting themselves to reality. This elastic access system provides real-time, highly granular usage data reflecting those token consumptions. So that data is available continually in order to feed back into the model and adjust your plans to be able to persevere in the direction that you think you've set or adjust accordingly. So I'm going to stop there. Have we got any other questions that haven't yet been answered?
I don't see any in the chat, Paul, but first of all, thank you all for sharing that. And Paul, really good to hear about the constant feedback loop that you're getting through usage data. Tristan, I assume that's the type of data that feeds very nicely into the hypothesis model and lets you really tune things as you go along. Any last comments you guys want to share on that before we have to part ways?
Just absolutely. I think this reinforces Alex's original point in that, just charging an additional monthly fee, like you can see from Paul's analysis and from the basic example I put up, how much risk that introduces into the system. And that is why most people are, erring towards a consumption model, because it reduces that risk. However, it does pass the risk on to the consumer, which some consumers may not like so much. So a lot of really interesting thoughts, possibilities for how you can develop your business model to really differentiate yourself.
Fantastic. And
if we go,
let's see. Yeah. So we'll go to the last slide, Chancellor, and give you Tristan's email address so you can ping him after the fact. But I know we went a little bit over, but it's such a good topic, very chock full of good information, and probably more discussion merited. But thank you very much, Tristan, Alex, and Paul, for sharing your insights and your experience today. Thank you in the audience for joining us today. Again, if you have any questions that we didn't get to, or as you watch the replay, which will be coming shortly to you, or as you just mull it over, please feel free to reach out to us and we'll get back to you as soon as we can. So with that, I'd just like to thank everybody again, and have a great day.
Thank you, everyone.
Go.
Thank you.
care.
Thanks, Jess. Thanks, Tristan.